Everyone able to see my screen?
Yeah, we can see, sir. It is clear.
Okay.
Recording in progress.
So we left with only one last topic, and that is tables. Correct? So listings we already discussed. Now the tables. Okay. So tables are also very similar to the listings only. Okay. See, observe here. So tables, not reports only. There are two types of reports will be there. ISS table, ISC tables. ISS reports and ISC reports. ISS is nothing but integrated summaries, safety tables, and efficacy tables. Okay, safety tables means in the tables we capture the safety information. Mostly we will derive the percentages there, column percentages, row percentages will derive. Wherein in ISC tables, means in efficacy table, most of statistics will derive. Like in mean, median, minimum values, maximum value, like the statistics we used to derive. So these are the final tables, final reports we will submit to the biostatisticians or clinical team or medical writing team. The next teams will submit these reports only. They'll review these reports only. Based on this review only, they can understand how the drug is performing, how effectively the drug is working. They'll get to know based on these reports. So overall, what is the final result of the drug? You can get to know from these reports only. To know the outcome information, the final outcome information, by seeing these reports, you can get it. End of the day, meaning will be same. To know the final overall result, how the drug is performing, to get to know, you can refer these tables. So we'll pass these tables to your next teams, biostatisticians and clinical teams. So they'll refer these reports and they'll come to understand. These reports mainly will submit to the FD. We'll also submit SGTM and RM datasets as well, along, but tables mainly it represents the overall statistics. Okay, so to generate the tables, again, what you require? Mainly you require the mock shells. First, they'll what tables you need to generate, they'll give the mock shell first. Last class we saw, right, for listings how they gave the mock shell, very similar way. But here the mock shells was different. Okay, and if they'll give an SAP document, in SAP document will contain if in those mock shell for how to derive any variables, what is the meaning of any variable or any label, they'll represent in the SAP document. And obviously your input datasets are HDTM datasets or RM datasets, and SAS tool is required. Okay, let's see. The programmatical approach was set. If any mock shell they were given, first check to derive that mock shell, what are the datasets are required. Take the datasets as input, then derive the required variables. As for mock shell, what are the columns you need? Those derive those columns. Remaining variables you can drop it. Then the remaining will be same. Use the proc template, write a ODS, if required, write a titles and footnotes, then ODS system, write a proc. These three are common steps even for listings and tables. Only mainly the major difference will occur here. So listings, it was so easy. Just you have to give the required variables, but for tables, you have to do the little bit derivations and all. So what type of derivations will do? Let me show you one mock shell, then you can understand. See, for example, this mock shell. This is one mock shell on safety table. Okay. So what they are asking, so they are asking something titled summary of population. So population of what? Intent to treatment, safety, efficacy, complete in 24 weeks, complete in study. Placebo, low dose, there is different drug name is there. The drug low dose, high dose, plus total. Maybe in this study, you have 3 drugs are there: low dose, high dose, and placebo. Okay, so they want a counts. In the tables, your note will give so much of information. Read this note, you'll get to know so much of information. Here, capital N. Here, capital N is there, right? What is the capital N is meaning? The capital N is column header represents the number of subjects enter into the study. That means who signed the informed consent. Okay. And the ITT population, what is the ITT population? We already discussed what is ITTFL. ITT population includes all the subjects who are randomized, who are ready to take the treatment, who are completed the randomization. For those subjects, we give the ITT plan. What is safety plan? Safety population includes all the randomized subjects known to have taken at least 1 dose of randomized study drug. Those who take at least 1 dose of drug. For them, we already gave the safety population. I mean, ADSL, we are already ready. The safety flag is ready, intent flag is ready, efficacy is ready. What is efficacy? The efficacy of population includes all the subject safety population who also have at least 1 post-baseline ADS program CBISC assessment. This specifically post-baseline, those who took this drug. That's the meaning. Completed week 24, those who completed the 24-week study, those who completed the complete study. So I need a count here. How this counts to be derived? Okay, everywhere in the tables, it's be end of the day, it's a counts only. Okay, you won't find any subject number, subject details, and all. It won't available in the tables. You will be having, you have to count, you have to derive the counts and percentages. Okay, how programmatically you have to approach? For example, for this table itself, how to approach? See, first, what you have to do it? First, you need to derive the capital N's. Okay. Yeah, something went wrong. Yeah. See, first, what we need to derive, you have to derive the capital N first. First, capital N derivation will do it. Okay, see, observe here. In the mock shell, whatever we have in the mock shell, first we have to derive this capital N values. Means, for example, in the total study, there are 100, let us assume there are 100 subjects. In those 100 subjects, how many are ready to take the placebo? How many are ready to take the low dose? How many are ready to take the high dose? Let us assume total subjects, placebo, there are 20 subjects are there, low dose, 40, high dose. 40 total, 40 plus 40, 80, 80 plus 20, 100. total 100. So this capital N count you have to derive first. Once the capital N derivation was done, then this is a small n derivation. In the small n derivation, first ITT flag. First ITT flag I need to derive. ITT, this row I need to derive. In this row, see, for each row, for example, in the ITT, for each column, for example, in the placebo. Let us assume ITT flag is nothing but what is ITT meaning? Ready to take the treatment. In the total 100 subjects, how many subjects are ready to take the treatment? Let us assume totally 50 subjects are ready to take the treatment. In those 50 subjects, how many are there ready to take the placebo? How many are there ready to take the low dose? How many are there ready to take the high dose? Simple. So this count you have to derive. So what is that meaning? In the total, under each column, you have to derive the small n. The counts you have to derive. Now small n also derive. Now what you have to do it? You have to derive the percentages also. How to derive the percentages? Very simple. Small n by capital N into 100. For example, placebo if we consider, in the placebo, small n is small 10, capital N is 20. 10 by 20 into 100 means the total 20 subjects, only 10 subjects are ready to take the treatment. So that is 50%. The percentages you have to display. In the low dose also, totally 40 subjects are there. Only 20 subjects have ITT flag is 20. So 20 by 40 into 100, 50%. Similarly, high dose. 20 people only, the 20 by 40 into 100, again 50%. So total overall also see, on 100 only 50% or 50 people are there, 50%. So like these percentages you need to derive. Once you derive the percentages, you combine both n and percentage. Concatenate n and percentage because I need both, right? Together. So like this 10 bracket percentage, 20 bracket percent, 20 for each placebo, low dose, high dose, total. Then finally in the report, you have to represent like this. See, for example, for ITT flag, you derive the values, you just transpose those values. It's supposed to come like this. Under placebo, how many? Under low dose for ITT, for high dose ITT, for total ITT. Capital N's we already derived. You capture those capital N constants as per the technique. Clear? Similar way you have to do it for safety also. So here we took the small n derivation, you did it using ITT flag, right? Now instead of ITT flag, take the safety flag. Now take the count. Again percentages, then concatenate. If you have efficacy flag, then next efficacy flag. So this capital N count will be constant. You no need to change the derivation, not required. Only the small n derivation and percentages derivation will change for each row. Clear? This is how you have to approach for any tables derivation. Programmatically also I'll show you for one table. Clear? Understand? So by the end of the day, you have to everything you have to derive the counts only. So this is all safety tables, mostly percentages. If you have some efficacy tables, if you observe, for example, if you observe any efficacy table, mock shell. See here. See, age was derivation. The summary of demographic and baseline characteristics. What is there? See, age. Age derivation you need to do it. So what they want n mean, standard deviation, minimum, maximum. So these statistics they want. These statistics I can derive from the proc means, right? Proc means data set name, variable name, give that age variable, output data set name. Okay. So automatically it is giving age. For age, it is giving the statistics, then mean, standard deviation, minimum, maximum. When you use the proc means, as it is those values, you have to represent here. Those counts. Efficacy tables means this proc means frequency values. In all other safety tables, we have to just derive the percentages. Okay, clear? All the tables same way. Okay, programmatically also I'll show you how to do the table program. Let's take one scenario. I'll take the adverse event table because mostly in real time, most of your tables are adverse event tables. If you take some 20 tables, if you do it, averagely 10 to 12 tables are adverse event tables only in real time. Remaining 5 to 6 tables are other laboratory tables, there are any exposure tables, demographic tables will be there. Okay. So you can, I'm going to give one code, adverse event code. So that code you can take it as a reference. You can derive for all adverse event tables. You can use it directly. Just a little bit modifications you have to do it as per the table. Okay, fine. See the table now. First of all, this is not a mock shell. It's already derived the output also. Generally, mock shell you won't get a numbers like this. Okay, you won't get numbers. They just give the header, required footnote. They'll give just give the titles. Just column names there. That's it. The data and all they won't give. You have to derive. Okay. So what is table? What they want? All the adverse events by system organ class and preferred term safety population. Okay. Means in the given data, okay, I need all the adverse events by system organ class and preferred term. System organ class is nothing but A bodies is variable. Preferred term is nothing but A decode variable. So what they want is the number of adverse events. First of all, I need in your study totally how many adverse events are there? 36 adverse events. So this is the adverse event count, okay, not a subjects count. How many adverse events are there? How many side effects are there? 36 adverse events. In those 36 adverse events, okay, these 36 adverse events are affected for how many body systems? See, these are the body systems. Gastrointestinal disorder, 11. Infections and investigations, 1. Investigations, 2. Metabolisms, 5. Musculoskeletal, 1. Nervous system disorder, 12. Okay, like this. Under each body system, how many adverse events are there? That count I take. Again, under each adverse event, so under each body system, there are different decodes are there. What are those, for example? Gastrointestinal disorder is 11. In these 11, how many are decodes are there? See, dysphagia, nausea, retching, vomiting. See, how many 1 plus 1, 2, 2 plus 6, 8, 8 plus 1, 9, 9 plus 2, 11. Total count 11. Like this. For example, nervous system disorder, if you take it, total 12 are there. 12 side effects. In those, how many are for each? Headache, hypoglycemia, things. 10 plus 1, 11, 11 plus 1, 12. Total, if you count also, it will get 36. Total body systems you are taking, right? 11 plus 1, 12, 13, again 12, 1. If you take this total, also you will get 36. So overall, to create this table, how many variables required? You just need a body system variable, a decode variable, and a term variable. These 3 variables if you enough. If you take the counts properly, you will get your table should be right. That's it, right? Any other variables are required here? Nothing. Just you are taking the counts in bracket. These are the percentages. Okay. So these are small lengths. I told you, right? These are the small lengths. What is the capital N? This is the capital N. So this is the capital N and this is the small n. In bracket, you have to mention the percentages. Okay, clear? Okay, let's see how to approach this program. So to derive this table, I need one data set. I have an AE data set also already. Okay, so this data set, based on this data set, I'm going to derive this table. Okay, to the code. See the first draft. I'm taking that AE data set as the input first. Observe here. So AE body system. Observe AE body system variable. So same terms are there. SOC is nothing but body system. Okay. Gastrointestinal disorder, nervous system disorders, metabolisms, respiratory infections, investigations. Under each body systems, you have different. For example, gastrointestinal disorder observed. Under each gastrointestinal disorder, they have different nausea, retching, nausea. For example, if you have the nervous system, headache, hypoglycemia. Under each body system, you have different decodes. Decodes are nothing but terms only. Decode is the dictionary name, E term is the exact name. Okay. Now I needed counts. These counts we are going to derive based on the it. Okay. See first. Okay, now approach. First, proc SQL. Select count. I'm taking distinct unique subject IDs. So I need a capital N. Okay. Totally, how many subjects are there affected with this adverse event? That count I need. I'm taking one macro variable called PO. Okay. This macro variable I'll use later for the percentage calculation. That's what first I'm deriving the capital. This is the capital N count. Next, I'm creating a table, TOT. First line. What is the first line here I'm deriving? What is the first line? Number of adverse events. Totally, how many adverse events are there? See. Select number of adverse event as cat. I'm creating one variable called cat. Cat n, numeric question data. See, count I'm taking. Count of 8. I'm taking as a variable as a from the given E data set. Next, SOC. System organ class. So how to derive the SOC? So here I'm taking all the AE body systems. Totally in AE body, under each AE body system, how many AE terms are there? See? AE bodies is I'm taking one variable, cat variable, cat n. AE bodies is variable I'm taking. The count of 8 when I'm grouping by AE body system. Means under each body systems, how many adverse events are there? The count will come here. Next, I'm grouping by AE bodies and AE decode. Means under each body system, under each AE decode, how much count? The count will come here. Okay, clear? So while taking itself also, select, if you observe here, this decode values will come after some space, right? If they want after some space. Space A decode. Space A decode to represent like this. So while taking A decode value itself, I'm concatenating with some spaces and A decode variable, taking as a cat variable. So in a cat variable itself, we have number of adverse event variable and AE bodies is variable and AE decode variable. Main variables are available in cat variable. In N variable, you have a counts. Okay, so just run. See, First POP macro variable is created already. First variable is first data set I'm creating TOT. What I told you TOT? TOT is nothing but see what we derived number of adverse events. Clear? Your first row is ready. Number of adverse events 36. For the second one, I'm grouping by AE bodices. Under each bodices, what are the AE terms count? The count I take. See, these are the body systems are there. See the cat variable. So these are the body system. Under each body systems, what are the counts? See, under gastro disorder, there are 11 adverse events are there. See, for example, in a nervous system disorder, there are 12 adverse events are there. Under each body system, how many adverse events that count? Now, third table, you are grouping by AE bodices and AE table. See, observe the cat variable. Under each body system, see, for example, if under each gastrointestinal disorder, these are the AE codes are there. For each decode, how many adverse events you have? That counts. Okay. In for example, in nervous systems also. Under each nervous system, how many counts are there? In each nervous system, there are three decodes are there. For each decode, what is the values? Count. Clear? So first you derive the total one. Then only for body system we took it. Around under each body system for each decode counts we derive. You have three different data sets. Then for the next step, you have to combine all the three. I'm going to set all the three. Set total data set, SOC data set, and TT data set. But observe here, along with the total count, I need a percentages also. So I'm going to derive the percentage. If you observe the percentage is not required for the first row. For all other rows, you require a percentage. So what I'm doing, if cat n is equal to 1, so means for the first row, cat n is equal to 1, means for the first row, you don't need to derive the percentages. The percentage column, I'm just passing the n number. N variable I'm passing. I'm just removing the leading training spaces. I'm creating some character variable. Okay. If cat n is equal to 2, for remaining two cases, if you have only bodices, if you have both bodices and AE decode, I need to derive the percentage. How to derive the percentage? See, first n variable I'm concatenating. In bracket only I need a percentage. What is the formula? Small n by capital N into 100. This is the capital N, right? P of macro variable I derive. This macro variable will be the capital N. Small n by capital N into 100. Simple. Put function will convert a numeric into character variable. Strip function will remove the leading and driving spaces. Then I need a brackets like this, right? Within the bracket, I need a values. So this brackets also I'm concatenating. First n value in bracket, that percentage. We run. See final data set. Observe here. There's a PCT variable I've created. First n, when cat n is equal to 1, we don't need to derive anything. Percentage. See, but in all other cases, you derive the along with n in bracket percentage is also coming. See, gastron disorder 11. So total percentage 73.3. Investigation for all the body systems, even though for all the AE decodes also. In the bracket, you are getting percentages. Just keep it in order. It's not coming in an order. You just sort it correctly. If you sort it correctly, it will come in the order. See. I'm just sorting in order. Okay. Under gastron disorder, these are the AE codes. Under nervous system, these are the AE codes. Clear? Now see, it's ready now. Your data set is ready as per the mock sheet. These are not required now for me. Only these two rows are required. One is cat row, cat column, and PCT column. These two variables are enough, correct? In the final output report, because only these two only they are asking. Remaining is not required. So in the final output proc report, I won't consider these two. I'll consider only these two rows, these two columns. Okay. So once your final data set was ready, remaining everything is same. Write a proc template. Done. The proc template is also done. Then give some titles and footnotes if required. See, for the title I required summary of table. Put into all adverse events by customer consult better. Okay. N is equal to, observe here, I need a number. That number I'm deriving from the POP macro variable, right? I'm just giving a pass in the macro variable. That value will resolve it. ODS RTF, write ODS system where you want to generate the table. Pass the step. Now generate the proc report. What is your final data set? Mention the data set name. In a column statement, mention which columns are required. Only two columns are required, right? I told you. One is cat column, another is PCT column. Just mention those column names. Define the each column. So here you no need to represent the column names. Okay, what they want, cat they represent as what is the column name they given, label they given. Just give that label. SOC/deferred time. For PCT, what is the column name they want in the value 10%. Okay. Remaining are constant in every proc report the same. Display option, left alignment. What is the column width you want for columns, even for headers also. Left alignment, what is the width if you want. Overall the proc report, what is the background colors. Overall header, report header, background colors, column width and ending. Close the ODS system, close the titles. That's it. Number 4. See, in your desktop location, project 1 location, the tables report is ready. I'm closing the previous one. I'm opening the new one. Done. The report is that's doing. As per the mock sheet, we have generated all the number of adverse events for each system organ class. For each preferred type, we have generated the counts and percentage. Okay. Clear this example? Understand, right? So every table is similar pattern. You have to derive the capital N, small n, then percentages. Everything completely depends on your programmatical skills. All the tables and listings, to derive the SDDMs and add-ons, you need a domain knowledge. But tables and listings completely a programmatical knowledge. Clear? Any doubts in this program? Anyone? Any questions, anyone? Manasa, Dharma, anyone? Shok, Deepa. Yes, sir.
This report only we are going to submit to FDA.
Yeah, the reports we'll submit to.
This is
We
the
won't.
final report.
Hmm?
This is the final report, sir. Now you have the recommendation.
Yeah, these are the 500 which we have to submit. Okay, like this, what are the reports they want? They'll give the mark shells. Okay, according to the mark shells, we'll generate and we'll give to them. Different mark shells they'll give. As per the requirement, we have to write a program, we have to generate a report. And that report will send to them. Okay.
Okay.
Yeah. So, clear? Any doubts in this question? So similarly, one more also I have. Okay. This one I'll give for your practice. The same way, previously, all adverse events like now n count you derived, right? Now this n count was divided into 3: mild, moderate, severe. Means under each adverse event, for example, total adverse events are there. In those total adverse events, how many are mild, how many are moderate, how many are severe? Again, in those mild, and each body system. And each body system, how many are? Okay. The same data set you can try it. Okay. Try from your end, practice from your end. I'm also giving the code also. You can also refer it in that one as well. Fine, very similar. You can try with your end. If you did not get an output, then you that code. Just for practice, it will be useful. I could have explained, but practice from your end, it will be good. Because every code, it will be same already. Okay, fine. Sure. Any questions, anyone? That's it. I have for the tables. Anything? That's it. I have for tables and lists. Any questions, anyone? So we have done almost everything. Okay. So actually, we left it only P21. Do you remember in the starting of the class, I was explaining these things. After the data sets are ready, you have to generate XPT files using XPT files. Again, P21. How to use this P21 report, P21 tool, Pinnacle 21 tool. From the Pinnacle 21 tool, okay, how to generate the P21 reports, how to generate the define the XML. Okay, this thing was spent. Clear? So this alone I'll explain tomorrow. Then tomorrow we'll wrap it up everything. Fine. This alone was pending. So this I'll explain. We got just a half an hour time. Like just half an hour to explain. Half an hour to 40 minutes. Look, it's already 9. So we'll do it, check it tomorrow. No problem. They have time. Fine. So tomorrow I'll finish.
Recording stopped.
For that, I'll share the all the interview questions, as clinical as interview questions, remaining test papers, resumes and all. I will share tomorrow. And if you have any questions also, you can ask me tomorrow. So tomorrow will be the last class. Okay. Fine then. Any questions, anyone? Any questions, Manasa? Sure.
No, Sudarshan.
If nothing is there, then
No, Sudarshan. I'm good. Thank you.
so tomorrow we'll catch up and we'll finish. Okay.
Sure.
Thank you.
Thank you. Thank you, Ira.
Thank you.
Thank you, sir.